When we look at the electron configurations of ions, it's important to pay attention to what's a core electron, what's a valence electron, what happens with our d electrons, right? So let's take a look at those. So first of all, let's understand cations versus anions versus what happens with our transition metals. All right, so cations. What do you remember about cations? Are they positive or negative? They are positive. So does that mean we are removing or adding electrons? Removing, because electrons are negative. So if I take away negatively charged things, I have more protons than electrons, and so I'm positively charged. So cations, these are formed when electrons are removed from the highest energy occupied orbital. Okay? Now, what about anions? Positive or negative? Well, if cations are positive, anions should be negative. All right, and so are we adding or subtracting electrons? We're adding because we need an excess of negative charge. So formed when electrons are added to the less energy unoccupied orbital. Okay. All right, now transition metal ions. So transition metals are metals. So do they like to form cations or anions? They like to form cations. All right, and so we add in our s electrons, and then we go back and we add in the previous energy levels d electrons. So s electrons, then d electrons. But the d electrons are not considered valence electrons. So they don't get touched until after the s electrons do. So the highest NS, so N being the energy level. So if we're in energy level 4, we're going to remove the 4 s electrons first. So the highest s electrons are removed first. Even though they are not the last added. Okay? All right? So now, when I look at this, if I look at something like silicon, my core electrons, all right, and that's where I can get that noble gas configuration. So I look at the periodic table. Silicon is in period 3, so my previous noble gas is neon, and so my core electrons here become that neon, and then I add in the 3s2, 3p2, okay? When I look at something like germanium, all right, my core electrons, even though now the d electrons are considered core electrons, they weren't filled with the previous noble gas. When I look at germanium, it's in period 4. So I've got argon, and so I would write this. I can write this as argon. Then that 4s2, then we go back and fill those 3d10, and then we add in the 4p2. And so it's the 4s and the 4p electrons that form the ion for germanium. Okay, so now, all right, so when I look at this, okay, let's say I've got something like aluminum. I've got neon, 3s2, 3p1, okay? So what does it look like when I make the aluminum ion? Well, aluminum is a main group, and it's going to make a +3 because it's in group 3a. And so my aluminum, I'm going to lose both the 3s and the 3p. So my aluminum is going to have an electron configuration that looks like neons. So it's going to get a helium, okay, 2s2, 2p6. Okay, so it's going to look like that. All right, now if I look at sulfur, okay, ground state of sulfur is neon, 3s2, 3p4. Now sulfur is a nonmetal, so to get my valence, I need to add in electrons. So sulfur is going to make a -2 ion for the sulfide ion, and we're going to get neon, 3s2, 3p6. So we look like argon. Okay, so my aluminum ion is isoelectronic to neon, and here I'm isoelectronic to argon. So isoelectronic, if you don't remember from your prep chem class, isoelectronic is having the same electron configuration. Okay, so two species with the same electron configuration are isoelectronic to each other. Okay, now when I look at my transition metals, so let's look at zinc first. So zinc has an electron configuration of, not in yellow because you can't read yellow, sorry, tapping the wrong things on my little screen down here. This looks better. Okay, zinc is going to have an electron configuration of argon, 4s2, 3d10. Okay, now zinc, when it ionizes, we know that most of the transition metals, we have to have a Roman numeral in order to denote what ion they're at. Well, zinc is one of the ones with a fixed charge. Zinc is always a +2. This is because the 3d10 configuration is really stable. So when zinc makes an ion, it only loses those 4s electrons, and we get argon 3d10. Okay, and it looks like this. Okay, so we take out those 4s electrons, and now we have our 3d10. Okay, so this right here, this is the correct way to write that configuration. We don't ever write the 4s0. That's just there as a placeholder here so that you see that that is where we took the electrons away from. Okay, when I look at something like iron. Okay, so iron, I'm going to get argon, 4s2, 3d6. Okay, so iron likes to make two different ions, iron 2 and iron 3. So if I'm going to make the iron 2, I would have argon 3d6. Okay, so I take off those s electrons first. And then if I want the iron 3, I'd have argon, and now I can mess with my d electrons. And so then I would end with argon 3d5 to look like that. Okay, and so that is how we do our electron configurations with ions. Hopefully exactly none of what I just went over was new material. This should be something that you went over in detail in your prep chem classes. So hopefully this was just a review and not anything new.